Hello everyone, this is Kanan Seri. In this video, we are going to discuss about how the ROMs are working and what are the different types of ROMs which is used in our recent days. So everything will be discussed in this video. So let's dive into the concepts. First of all, what is ROM? ROM is a read-only memory. It is a non-volatile memory that stores permanent instructions required for a computer or a microcontroller to sort and operate. So basically, the data which is stored inside the ROM is uh, read-only data, which means we can't able to write or we should not change the data at any time. So at running time. So these type of data are called as uh, uh, permanent data. So which means so if we want to turn on the computer means when I put the turn on button on the computer, so the computer gets the BIOS file inside the ROM. The RAM gets this BIOS file and it starts a processing and it goes to the data to the processor. The processor processing the data, and finally it checks all the hardwares whether all the hardwares are working properly. Everything will be checked, and finally it will display the wallpaper of the laptop, wallpaper in the display. So everything will be displayed. So during this short operation to the wallpaper display, large amount of data are processing at a time. So these data will not change at any time inside the computer. So these type of unchangeable data are stored in the ROM. Okay, so this is called permanent data. Okay, so basically ROM is used to read the data. We can't change the data. So that's why I'm explaining this by using this example. So we can't able to write this BIOS menu at a time. If you want to write, if you write this BIOS menu, means the entire system will not works, right? So that's why we should not write this data. These type of data are stored in the ROM. Okay, and also it is a non-volatile memory. There is a difference between volatile and non-volatile. Volatile means whenever you are writing you are writing the data, uh, data will be lost when the power is off, which means when the power supply is removed in your computer or laptop, the entire data when the memories will be lost. Example is RAM. Okay, RAM is a volatile memory. So ROM is a non-volatile memory, which means when the power is turned off, the data is stored inside the transistor, so inside the memory will not get lost. Okay, so this ROM is a non-volatile memory. Okay, so this is the simple it's explanation of the RAM and ROM. So here I already say computer BIOS UFA, which means these BIOS menu are stored inside the ROM. So when the power is turned on the computer, the data is fetched from the ROM memory, and it start the processing, and the processor start the processing by through the RAM. So everything will performed by inside the ROM. Okay. So controller, inside the controller we are storing the firmware, right? Firmware is nothing but you are writing the code to operate the data, operate the actuators or sensors, right? So if you want to look at if you want to turn on the LED turn on and turn off continuously means I write a specific code in a integrated environment, and I just dump the code inside the controller. And the data should not be changed at the running time, right? If it change if the code is changed, it means the entire thing will not work, right? So this type of memories, unchangeable firmwares are stored, unknown data are stored inside the ROM. Okay. So and then printers, routers, TV, washing machines. Washing machine means so if I want to put 30 minutes timer inside the washing machine means so or rinse or everything, whatever the operation performs in on the top of the washing machine. I put I press any buttons on the top of the washing machine means it sends the data to the controller. The controller gets gets the uh, gets a stored code based upon the user input. For example, if a user put 30 minutes to rinse in a washing machine means this 30 minutes rinse operation, to perform this 30 minutes rinse operation, there is a code stored inside the ROM. So this RAM gets the data from the ROM, and do the performed operation, which means this 32 bits working concept, when working with coding is will be stored in the ROM permanently. We can't change that code at any time. Okay, so the controller gets the files based upon the user input, and it perform the actuators. Okay, so this is the firmware stored inside the ROM. This is a concept of ROM. Okay, so yeah, there are different types of ROMs used in all over the world. Okay, so MROM, masked ROM, PROM, EEPROM, EEPROM, flash ROM. Let's be discussing one by one. Okay, first of all, MROM, masked ROM. Masked ROM is a type of ROM in which the data is permanently written during the manufacturing process. These type of ROMs are it's a very first ROM introduced in the 1980s period. Okay, so these ROMs basically it stores the data during the manufacturing process. For example, if I want to turn off the LED continuously, means I taken this code and I write these operations inside the or inside this controller inside this ROM during the manufacturing process, which means whenever you put this MRO chip in any controller or any working circuit means this ROM contains LED turn off ROM. Whenever put in the top of the circuit means when you put this ROM on the top of the circuit means it turn off LED continuously. We can't change this data at any time. Okay, um, this is the MRO definition. So once manufacturing is completed means the content inside the ROM cannot be changed. This is the MROM. And PROM. PROM is a programmable read-only memories. This is the type of the ROM. It is a blank. Okay. During the manufacturing process, the manufacturer should not write anything inside the ROM. So after manufacturing, the user can program the code and it should be only once. Okay, the programmable code word should be only once. Should not must be only once. So we can't change after when you dump the code inside them once after. Okay, so which means in previous slide we discussed about MROM means. So MROM means nothing but if the manufacturer decide what should be inside the ROM, right? So in PROM we can decide what should be inside the ROM. So okay, so after the program is done means data will become permanent and cannot be erased. Okay, so this is the one of the examples of the PROM and EEPROM. EEPROM is nothing but erasable programmable read-only memory. It is a type of ROM. Okay, that can be programmed erased using high volatile memory. I mean ultraviolet light and reprogram multiple times. So it is a type of ROM, but we can erase the data multiple times, right? So which means so the data in the previous two slides we discussed about the MROM and PROM, which means we can't change the data at any time. Once the code is written, I mean once the data is written on the once the data is written on the ROM, right? But EEPROM we can change the data multiple times by using to show the ROM IC to the UV lights, UV lights, right? So which means when the user write the code and the code is dumb inside this ROM. So if the user want to change this code means uh, uh, they have to showcase this. They have to show this EEPROM to the UV light, which means the UV light falling on the top of the EEPROM. After that, during this UV light passing inside this ROM IC, the entire data inside this will be lost. Okay, so after that we can able to rewrite the program. Okay, so but to do this we have to remove this chip from the circuit board. Okay, we can't directly showcase things you will let inside the circuit board. We have to remove each time. We have to remove room each time. Okay. So and after that, EEPROM is introduced. EEPROM is nothing but electrically erasable programmable readable memory. So in previous slide, we are erasing the data by using show the EEPROM to the sunlight or UV light, right? Here we can erase the data by using electrical signals, and also we should not we can't able to, I mean uh, we don't need to remove the chip on we don't need to remove the ROM chip on the circuit board. Okay, when previously we got to remove separate remove chip on the circuit board each time to erase the data, but here we don't need to remove the chip. So we can delete the data and we can read the data by using electrical signals. Okay, so when electrical voltage are used to write and read the data continuously, and we can and it is one of the compared to the previous all three ICs, this EEPROM ICs is much faster than, but it is much slower than the flash memory. Let me discuss what is flash memory. Okay, flash ROM. Okay, so it is the this is the type of ROM, one of the efficient ROM which is used in a day-to-day life. Okay, in our computer or phones, we are using this flash technology to design the ROM. Okay, so you can able to see in your computer and for mobile phones. Okay, this is the newest technology used to design the design the ROM. Okay, so it is a type of EEPROM. So what we discussed in the previous slide, it is also type of the EEPROM. But we can instead of deleting data one byte at a time, we can delete the multiple byte at a time. Which means in previous slide we can delete the data, delete the one byte of data by using electrical signal at a time. But in flash memory we can delete multiple byte of data at a time. This type of multiple byte is called as a blocks. Okay, so it is much faster than EEPROM and its high storage capacity. So and also there are two types of flash memory: NAND flash or non-flash. Let me discuss one by one. Okay, so NAND flash. NAND flash is a type of flash memory in which memory cells are connected in series. This memory cells in nothing but it's a transistors. Okay, transistors are called as a memory cells in this in memory architecture. So NOR flash is a type of memory. Each memory cells are connected in a series format. This is how this is how the transistors are arranged together. So, providing high storage density and for fast block-based read-write operations. Okay, and fast read and write operation, slow random read and NOR. Okay, let me discuss from the slides of the NOR operation. So basically, if I want to write a data of 11111 means we can directly pull up this bit line upward, which means the supply goes inside this each transistor at a time. Okay, so at a time the supplies goes inside this stuff. Okay, so if I want to change the data to 0 0 0 0 0 0 and multiple zeros, multiple zeros inside the transistor means I need to pull up this bit line to downward, which means the supply will not goes, and the supply goes to the ground transistors. I mean ground. The entire supply will be lost, and the entire data stored inside the transistor becomes zero. This is the efficient read and write operations, which means efficient write and erase operation. Okay, so we can write multiple transistors at a time. Okay, and also we can erase multiple transistors at a time. If you want to write the data means I just need to pull up this bit line upward, which means the supply goes into the all transistors. Okay, so if I want to erase the data means I need to pull down this bit line to the downward, which means all the supply will be lost, and the transistor stored in the supply will be moves to the ground. Okay, so this is how the read and write read and write and erase operations are performed inside the transistors. And again, it's much slower than the read operation. Why it's slower than read operation? Because I will explain very deeply this concept. If I want to read bad line 2, which means I need to go one by one transistors because it is seriously connected. It's not a parallel connection; it's a series connected, right? So I need to go transistor. I need to check one by one, right? So if I to read this bad line 3 to read the data in the bad line 3 means I need to check this transistor one by one. After reaching this data, I will check. I can able to check the data stored in the bad line 2. Here, the time taken to read this multiple, the time taken to read this line 2 is more compared to the RAM flash. I will explain how the RAM flash reading operation is efficient. Okay, so if I want to read the line 2 means I need to check. I need to check, and I need to move each transistor one by one to reach the final destination, right? So this time taken leads to the that's why it is slower random read than not random read means this is what I explained previously. It is a random read. Okay. So in NOR plus, we can directly read each memory at a time. Okay. So this is why the reading operation NAND plus is not suitable. For write and erase operation, we can this NAND operation is very efficient. Okay. So compared to NOR plus, for write and erase operation, NOR plus is more efficient than NAND plus is more efficient than NOR. Okay, so that's why this is the NAND plus working, and then so that's why mostly this NAND plus is mostly used in SSD, HDD, pen drive, and etc. So because these these type of memories are used for writing and erasing operation, which means we can store multiple photos, multiple videos, everything will be stored inside the SSD, HDD, pen drive. HDD means hard drive. Okay, SSD means it's a memory it's used in your laptops and computers, right? So pen drive is a smaller size of memory which store my huge data, huge data in a smaller size. So these three type of memories are used to write and erase operation at high speed, right? If I want to delete images inside the SSD means the delete operation should perform very efficiently, right? So if I want to if I want to store the photo inside the SSD means the data should be stored at faster speed, right? So to do this, this non-plus architectures are used to do design this SSD, HDD pen drives, or okay, etc. Okay. So, but for read operation, this non-plus are not used. So that's why we are using NOR plus. Okay, NOR plus is also type of memory in which memory cells are connected in a parallel. Memory cells are produced as transistors. Okay, that's why technically we call it as a memory cells. Okay, this transistors connected in a parallel size. Parallel in series size means all the transistors connected together. It's called a series. But in parallel means each transistor connected connected there is a bit line is connected to each transistor. Here the bit line is connected to the bad line 5. Here the bit line is connected to the bad line 3 and bad line 4. So and also ground is placed at the mid of bad line 3 and 5. Bad line 4 and 5, which means that each transistors are separated. Okay, so you can now you can able to understand. Random read operation is efficiently performing in NOR operations. Okay, so allowing direct access to into any memory location. This is what I said. We can directly access the any memory location at any time. This is the one of the best. One of the one of not to not plus. This is the not plus. This is better to but better used for read operations. Okay. So if I want to get the data of bad line one means so I can directly go this through this line. Okay. So if I want to get the data of bad line two means I can directly go this line. Okay. So I don't want to read one by one transistors. Okay. I can directly access the transistor at a time. So that's why random read operation is very efficient in a very efficient not plus, but in NAND plus. Uh, uh, Write and erase operation is much efficient. Okay, so then yeah, slower faster read speed, slower write and erase operation, lower storage capacity. Okay, which means here multiple storage data multiple data are stored in a single blocks. Okay, this is called blocks. Okay, this is I already say this is called this multiple transistors, multiple memory cells are together called as blocks. But in non-flash, each block contains only two cells. Not a two cells. Each block contains only one cells. Okay, which means the storage capacity is much lower in each block. That's why it is called lower storage capacity. And this BIOS, UMA, UEFI, firmware and computers microcontroller concept, which means this not plus basically used in microcontrollers. So basically, I already say in microcontroller we are writing a code of 10 on 10 on 10 of LED in LED means so I just dump the code inside the ROM. If to do this, I mean when the controller turns on means it start executing the code, right? So inside during this process we should not change the code inside the we should not change the code during the controller operation during the controller running time, right? So the data should be frequently fetches and data should be read. I mean, the instruction should be read and the data should be fetched much faster, right? So all the data are all the instructions are stored inside this firmware, right? Firmware means nothing but it's a code. Okay, you can say you can find it as a code. Okay, code. You are writing in a writing the embedded C inside the Arduino IDE, right? So this code is called as a firmware. So in firmware we are giving add operation or LED turn off operation. Everything you are giving inside this firmware, right? So to read each instructions continuously, right? So to do this, to read much faster, non plus technologies used. So NAND plus or NOR plus is a type of technologies. Okay, it's not a SSD or custody. It's a type of technology which is used to design the memory. Okay, so in SSD they are using NAND plus, but in to design the ROM for controllers and and computer computer I mean to design a those are the ROM for computers and microcontrollers. We are using BIOS and UEFI firmwares. Okay. I mean, to design a NOR plus are used. Okay, NOR plus type of technology which is used to design design the ICs inside the controllers and microcomputer. So laptops or computers, this BIOS and UEFI firmwares are usually stored in the ROM. Okay, because we should not change this data inside we should not change the data when the computer is turned on, right? So due to this, ROMs are used, but in controller, controllers we should not change when the code is running, right? When the controller starts operation means we should not change we should not interrupt this interrupt its operation, right? So that's why. ROMs are used in the, I mean, NOR plus is used in the microcontrollers. Okay, so NAND plus are mostly used in the SSD, HDD, pen drives, and this type of efficient write and erase operations. These non plus are used, and efficient read operation NOR plus technologies are used. Both are technologies, different technologies used for various operations. Okay, so both have unique features. These non plus and non plus are used in recent years, and there is advanced versions or advanced technologies are used nowadays. By using nowadays in electronics industry, let me see in this about advanced technology in upcoming videos. Okay. Thanks for watching this video.